Next question. And again, I'm telling you, you need a real hard work. Don't take it like 10th standard. I know there's a, don't go for a temporary comfort. That will never last. Next. What is the angular acceleration of a particle moving in a circle of radius r with an angular speed omega? What is the angular acceleration of a particle? That means alpha. What is the angular acceleration of a particle moving in a circle of radius r with the speed omega? What is the angular acceleration of a particle moving in a circle of radius r with an angular speed omega? Angular acceleration alpha is equal to r omega, isn't it?
Yes, sir.
Yes, sir.
V is equal to r omega. Wait, V is equal to r omega. dV by dt is equal to r into d omega by dt. So this is r alpha, this is a. So angular acceleration they asked, right?
Yes,
Alpha is equal to a by r. Linear acceleration by radius, isn't it?
Yes, sir.
What is the angular acceleration of a particle moving in a circle of radius r with an angular speed omega? So omega is angular speed, r is radius, so angular acceleration is dv by d omega by dt, isn't it? So d omega by dt is a by r. Two bombs, B-O-M-B, two bombs of mass 20 kilogram and 30 kilogram are thrown from a cannon with the same velocity in the same direction. Are thrown from a cannon. Two bombs of 20 kilogram and 30 kilogram are thrown from a cannon with the same velocity in the same direction. Which bomb will reach the ground first? Which bomb will reach the ground first?
with the same velocity and
two bombs of 20 kilogram and 30 kilogram are thrown from a cannon with the same velocity in the same direction. Which bomb will reach first?
Sir, 30 kg one.
Huh?
sir,
30
30
one.
kg.
the 20.
Sir, wouldn't they reach at the same time? Because
Same time. There's many example
reach at the
animations we
same
have
time.
seen. Two coins they are throwing the same time. Okay, they may have different range, even then they will reach same time because vertical velocity will be same. Vertical velocity will not change. Clear?
Yes, sir.
Yes, sir.
Because it will have a same acceleration. Vertical acceleration will be same. For whatever be the mass of the body, vertical speed will be same. So same time they both reach. It is independent of mass. Now, two cars are going in two concentric circular orbits. Two cars are going in two concentric circular orbits. Concentric means same center, okay? Two cars are going in two concentric circular orbits of radius R1 and R2. Radius R1 and R2. with angular velocities omega 1 and omega 2. With angular velocities omega 1 and omega 2. What is the ratio of their linear velocities? What is the ratio of their linear velocities? V1 by V2.
Sir, we'll take V is equal to R omega into, right?
V1 is equal to R1 omega, V2 is equal to R2 omega, isn't it?
Yes, sir.
So we
Yes.
R1 by R2.
R1 by R.
No, their velocities are different, right? So R1 omega 1 by R2, their velocities are not same.
Yes,
So
sir.
R1 omega 1 by R2 omega 2. Okay? Their velocities are not same. They have omega 1 and omega 2, different angular velocities. Okay?
Yes, sir.
What is the ratio of their velocities? V1 is equal to R1 omega 1, V2 R2 omega 2. Next. Two equal forces. Two equal forces have their resultant equal to either. Two equal forces have their resultant equal to either. What is the angle between them? Or inclination between them? What is the inclination between them?
Sir, two equal forces have their
Two equal forces have their resultant equal to either. Two equal forces have their resultant equal to either. What is the inclination between them?
Sir, 45 degrees. 45, I think.
You just take parallelogram law of extradition and check what we have done. That means here if it's 5 Newton, other also 5 Newton, resultant also 5 Newton. What is the angle?
Half of 9.
45
degrees.
How much? I did not hear you.
Sir, 45.
45.
45.
Yes,
5
sir.
Newton, 5 Newton. So will the resultant is 5 Newton?
Oh,
120 degrees. Sir.
Is the resultant 5 Newton?
No, sir.
No, sir.
Then what is the angle?
So 120.
130?
120.
Huh? Turn your notebook. It is there, it's written. The question which is directly coming from notebook, you are unable to answer. Take your notebook and see. It is in vector. Which vector gives each side same and resultant also same. Very specifically, I told this one to you.
So 120 degrees, sir.
120 degree. Very clearly. Parallelogram law, triangular law, all the way we proved it. Many times I told you this one. 120. Or you can prove it is equal to a squared plus b squared plus 2ab cos theta. This is a proof. Then r is equal to x. Because r, a, b all are same. X squared plus 2x. A into b again x squared cos theta. Now here x squared is equal to 2x squared plus 2x squared cos theta. Isn't it? Yeah. Then here, wait. R is equal to x squared plus 2 ab x squared cos theta. So both sides square root x squared is, this will be x squared plus x squared 2x squared plus 2x squared cos theta. Now this x squared you take this side. So x squared minus 2x squared is equal to 2x squared cos theta. This is minus x squared. It's equal to 2x squared cos theta. Now minus x squared divided by 2x squared is equal to cos theta. X squared cancel. Cos theta is equal to minus of theta is equal to 120 degree. So first term will be, I think, horrible for me.
So it should be positive 1 by 2, right? It's
How
transposed.
positive? Minus x squared, right? So x squared cancel, minus 1 by 2 cos theta, isn't it? Okay.
Yes, sir. Yes.
A lady walking towards east. A lady walking towards east. This is east. This is west, north. Not north, south. This is east. This is west. Wait. A lady walking towards east on a road with a velocity of 10 meter per second. Velocity of woman. Encounters rain falling vertically down. Rain falling vertically down. So this is the velocity of the rain.
Sir, we have done this question, sir.
We have done, but when you next time you're not doing right, and I'm telling you. Revision time, these are all we have done. You take the notebook and read, but you're not revising, isn't it? Try. A lady walking towards east on a road with a velocity of 10 meter per second encounters, write the question if you want. A lady walking towards east on a road with a velocity of 10.
Yes, sir. We are writing the question, then we'll
You
finish.
want me to do that, or will you do? Will you try?
The notebook, sir.
Sir, the question, can you give again?
Yes, sir. We didn't complete the question, so then we can try.
This all from Together with Physics, huh? Okay. A lady walking towards east on a road with a velocity of with a velocity of with a velocity of 10 meter per second. 10 meter per second. Encounters rain falling vertically, with a velocity of 30 meter per second. With a velocity of 30 meter per second. At what angle she should hold her umbrella? At what angle she should hold her umbrella to protect herself from the rain? To protect herself from the rain. To protect herself from the rain. You want me to solve it?
Yes, sir.
Yes, sir, you can solve.
A lady walking towards east. Walking towards east. That means west to east. On a road with a velocity of 10 meter per second. Velocity of 10 meter per second. Rain falling vertically with a velocity of 30 meter per second. Rain falling down with a velocity of, this is the velocity of the woman. Velocity of woman, velocity of the rain, 30 meter per second. At what angle should she hold the umbrella to protect herself from the rain? First of all, looking at the diagram, will her hold the umbrella? Okay, just a minute. Will her hold her umbrella straight or this direction or this direction?
Sir.
Huh?
Sir, east direction.
49 present, sir.
Sir, towards west, sir, slightly.
Towards
Towards
east.
west, like this.
Yes, sir.
No,
That
sir.
means you are going in a rain
No,
umbrella.
sir. Towards
Sir,
east.
towards
It will be
east.
Towards east, sir.
Towards east,
Coming
sir.
from the east side.
You didn't travel in rain anytime?
Yes, sir. So towards east, we'll hold the umbrella.
Yeah, you will walk where you're walking to, that side only you will hold forward.
Otherwise,
Isn't
the
it?
rain will fall on our head.
Ah. If you're walking forward, you will hold the umbrella towards front, isn't it?
Yes.
Not back.
Yes, sir. Not bad.
Yes, sir.
Okay. So first of all, that idea you should have. So this is the position of umbrella now. Okay. Now actually, look here. This is the direction rain falls. This is the relative velocity of the rain. Relative velocity of the rain with respect to women. That's why she is holding umbrella in that direction. Is it clear?
Yes,
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 sir.
sir.
Ah.
Yes,
So
sir.
this beta only are calculating. And this also beta. So this is 30. Here we have to reverse this, isn't it?
Yes, sir.
This you have to reverse. This is minus VW. Okay? You know why we are reversing?
Yes, sir.
Vector subtraction. Because relative velocity of the rain with respect to women is equal to VR minus VW. Isn't it?
Yes,
Yes,
sir.
sir.
Ah.
Yes, sir.
If you're taking this side, it means VR plus VW. That will give you resultant velocity. We are not calculating resultant velocity. We are calculating relative velocity of the rain with respect to women. According to that, we have to turn your umbrella. So relative velocity means VR minus VW should come. So your answer should come this side. See, that's what minus. That's why see direction of the relative velocity also coming this side. So that we can write tan beta is equal to opposite side. Opposite side is 10. Okay, 10. Adjacent side is 30. That means 1 by 3 tan beta. Beta is equal to 18 degree, answer will come. (18 degree 16 minutes approximately). Same problem we did in our notebook also. And she will hold the umbrella towards west. Okay, 18 degree tilted towards west. Okay.
Okay, sir.
Oh. Now we are going to laws of motion.
Sir, you will be present in library today.
What?
You will be present in library today.
Definitely, definitely. I'll meet everyone's parent. I will ask them whether they are observing you at home. This is because like PTA, right?
Yes, sir.
It's an important subject. I will tell them nobody is listening in the class. Nobody is answering anything. All complaints I'll give. I'm writing in a A4 size sheet, all complaints about it. But there are some names I have regular absent. Give the magnitude. This is numerical, I think. Wait. Numericals we'll do later. We will do one more questions first. Numericals already we have in the notebook that you can finish. Okay. I'll give you one more questions. This is the problem for you. A bomb at rest. A bomb at rest. First question. A bomb at rest explodes into 3 parts. Explodes into 3 parts of same mass. A bomb at rest explodes into 3 parts of same mass. The momentum of parts are minus 2I and Pj, Pj minus 2i and Pj. The momentum of the third part will have a magnitude, then momentum of third part will have a magnitude of, momentum of third part will have a magnitude of A bit P, B bit root 3 of P, C bit root 3 P, this is root 3 into P, this is root 3 of P, then D bit 0. The bomb at rest explodes into 3 parts of same mass. So one goes here M, so this is M by 3, total mass M, this is M divided by 3, this is M divided by 3. Okay, because the momentum is conserved, right?
Yes, sir.
So these broken pieces are equal size, equal masses. Say they go equally opposite directions. Okay, right. The momentum of two parts are minus 2i. So clearly they said minus 2i. Here you mark. This is the mass minus 2i. That means here one piece goes this way, minus 2i. And Pj, one is going to here, Pj, which is the direction third one goes. This is M, this is M. What the direction third one?
Downwards.
What will be the momentum of third one? That's a question. Momentum should be conserved, right?
Yes, sir.
Yes, sir.
Yes.
So before collision, before explosion, 0.
Yes, sir, it is 0.
Sir, how 0?
At the state of rest,
Bomb at rest.
Inside rest,
it
that's right.
will be 0.
After explosion, total linear momentum must be equal to total linear momentum before explosion and after explosion must be equal, right?
Yes, sir.
Yes, sir.
So after explosion, minus 2i plus Pj plus x.
Excuse me, sir. There's a boy in the waiting room.
Which one?
Boy is there in the waiting room.
Tell me. So after explosion, minus 2i and plus Pj plus x is equal to 0. Okay, then what will be x?
So my 2i minus Pj.
2i minus Pj.
But the options are P, root 3P, root 3 of P, P and 0, right? Once again, we have to think of it.
Yes, sir.
A bomb at rest explodes into 3 parts of the same mass. The momentum of 2 parts are minus 2i. One is going here with a mass into 2i. So momentum P is equal to this side. It goes, right?
Yes, sir.
That means the momentum of 2 parts are minus 2i. So this is minus 2i, they have given directly. Okay, minus 2i. And Pj, other one is going to this side. What is this question? 1 minute. The momentum of 2 parts are minus 2i and Pj. This is minus 2i and this is Pj. The momentum of the third part, that's a question, right? So total momentum
We have
before
to find
explosion is 0
magnitude.
and total momentum after explosion is minus 2i
2i plus pj.
minus 2i plus pj, isn't it?
Yes, sir.
So here we have to take vector addition, I think. Let me check it, okay? That is ij 90 degree, 4 plus 1. No, 4 plus p, isn't it?
Yes, sir.
Sir,
P squared.
Square, right?
4 plus p squared, right?
Yes, sir.
Yes, sir.
Root 3p, 1 minute. That is root of 4 squared plus pj. Let me check it and tell you. I think some data missing. I'll tell you this problem. Leave it. Okay.
It's root 3p.
Huh?
I think it's root 3p.
Root 3p.
Yes. By
How it's coming?
considering
0 is
2
equal to?
squared, root of 2 squared and 1 squared.
Once again,
1
2
squared.
squared. 1 is 2 squared. Just now we did. That is 4.
Yes. Plus
Then p.
1.
Then p squared, right?
Yes, sir.
Then how root 3p will come? That's what I'm saying.
Sir, I guess that pj given
Sir, we can find P and then we can find the magnitude. Right? From this we can find P.
The question is, what will be the... one more plus x is there, no, here. One x is there.
x squared, sir.
X squared. Let me think and tell you. No need to waste time. I'll tell you. By next class, I'll tell you. Okay, leave it. Because we will get the answer. Answer is here, but we need to know how it's obtained. I'll tell you. Wait. The proper use of lubricants. Next question. The proper use of lubricants cannot reduce. The proper use of lubricants cannot reduce. The proper use of lubricants cannot reduce A bit static friction, B bit inertia, C bit sliding friction, D bit rolling friction. Now, the proper use of lubricants cannot reduce which of these?
Inertia.
Inertia has no connection with lubrication. That depends on mass. But all friction can be reduced by lubrication. Next question.
The last option is rolling friction, right?
Which
Last
one?
option.
Last option,
Last
rolling
option.
friction. Rolling friction. Next question. During the motion of a lift, apparent weight of the body becomes twice its actual weight. Apparent weight of the body becomes 2 times its actual weight. Becomes 2 times its actual weight when A bit lift is moving down with acceleration g. Lift is moving down with acceleration g. Lift is moving up with an acceleration g. Lift is moving up with an acceleration g. C bit. Lift is moving down with a uniform velocity. Lift is moving down with a uniform velocity. 9.8 meter per second. Not second square. 9.8 meter per second. Fourth bit. Lift is moving up with a uniform velocity. Lift is moving up with a uniform velocity. 9.8 meter per second. So we know R is equal, apparent weight R is equal to mg plus A. because we studied 3 situations. One at rest, no change in apparent weight, isn't it?
Yes, sir.
Second one, when lift is going, we feel heavier.
Yes, sir.
If it is accelerating, weight appear to be increasing. G plus A, we feel heavier and heavier. If it is coming down, we feel lighter. So there we use R is equal to M into G minus A. And you know, for a freely falling body, A is equal to G, R is equal to 0, we feel weightlessness. I told you about it, and I have sent you a video, that rocket video, it's falling down. I don't know how many of you have seen it. After this class, I have sent a video to you.
Okay, sir.
One travelogue, some people are going in a aircraft and dropping
Yes,
down.
sir. Yes, sure, sir.
I have sent to you. Then here, constant velocity, rest almost same. So this can be the answer because weight appear to be doubled, right?
Yes, sir.
Weight appear to be double means it must go with an acceleration upward. So out of 3 options, option B is the correct answer. No need to calculate. It's very clear concept.
Sir, but I have a doubt. When we are going up, the G will be equal to minus 9.8 meter per second square, right?
That is in that numerical only, right? Freely falling body.
Okay, sir.
And only in that particular area, only in freely falling body, there we give a sign convention.
Okay, sir.
Okay, right. So G plus A. So here you can see G should increase in such a way, then apparent weight is found to be doubled. For example, if A is equal to G, so this will be 2G. Then R is equal to 2mg. 2 times appear to be increased. Isn't it?
Yes, sir.
Yes, sir.
So your answer, lift is going with an acceleration G upward. Okay?
B, option B.
Option B. Clear? Without calculation itself, we can find out.
Yes, sir.
Because when lift is at rest, no change in weight. When lift is going upward, we feel heavier. When lift is coming down, we feel lighter. Constant velocity also, we don't have any weight, any change, change in weight. Next question. A particle of mass m, moving with a velocity v, a particle of mass m, moving with a velocity v, strikes a stationary particle, a particle of mass m, moving with a velocity v, strikes a stationary particle of mass 2m and sticks to it. The speed of the system will be, A is equal to v by 2, B is equal to 2v, C is equal to v by 3, D is equal to 3v. So again, a particle of mass m moving with a velocity v strikes a stationary particle
Sir, V by
of
2,
mass
right?
2m, their velocity 0
Yes, sir.
and
Sir,
sticks to it.
sir, the velocity of the system will be
V by
2,
3.
right?
Let us calculate. Now these both will travel together with a velocity v dash, isn't it?
Yes, sir.
So law of conservation of momentum. Before collision, m into v plus 0. After collision, this become 2m plus m, 3m. 3m into v dash, isn't it?
Yes, sir.
Yes, sir.
Now mv into 3mv dash here. M cancel. So v dash is equal to We made a mistake here. Check. Before collision, total linear momentum, this is m into v, plus this is 0. That's equal to, after collision, both will gain a common velocity, right?
Yes, sir.
Isn't it? So
Yes, sir.
m
Yes,
plus
sir.
2m into v. So mv is equal to 3 mv. M cancel. This is v dash, v dash. Then v dash is equal to v by 3, isn't it?
Yes, sir.
Yes.
Correct.
Yes.
V by 3.
Here we are using law of conservation of mass momentum. Yeah.
Law of conservation of linear momentum. Can I go to next numerical?
Yes, sir.
Yes, sir.
Okay. In an elevator, moving vertically up, with an acceleration g, the force exerted by the passenger, of mass capital M, force exerted by the passenger of mass capital M is A bit mg, B bit half mg, C bit 0, D bit 2 mg. That means I told you, suppose you are standing, that was the example I told you, you are standing on a weighing machine. Clear? When you go up, how much weight you experience onto the floor, same weight is coming as reaction. That reaction only reading of that weighing machine. I told you that day itself.
Yes, sir. Sir, excuse me, sir. Actually, what is the C bit?
Huh?
What is the C bit?
0. C is 0.
0.
2 mg is dense.
So here that day itself, this example I told you. Like this only explain this concept. We are standing on a weighing machine. If it's at rest, our real weight will be measured by the weighing machine. But when you go up, weighing machine will show large reading because that time, because of apparent weight means that time you feel.
Yes,
You
sir.
exert a force onto the floor. So reaction by the floor is R. So what is the apparent weight? That is a reaction, isn't it?
Yes, sir.
Yes, sir.
That is read by that speed of, your weighing machine.
2 mg will be the answer.
So here it tell me
2
which one?
mg.
R is
2
equal to
2
2
mg. So reaction R is
2 mg.
equal to, what is that formula we are using? Reaction R is equal
m
to
into
M into
A plus
G
G.
plus A.
M
A
into
plus
A
G plus A. So M into
G
G plus A is
plus
equal
G.
to G. That will be 2
2 mg.
mg. So his weight appear to be double because reaction is double.
Yes, sir.
Next, for a body moving with a constant speed, in a horizontal circle, a body moving with a constant speed in a horizontal circle, which of the following remains constant? Which of the following remains constant?
So, sir, can you repeat?
For a body moving with a constant speed in horizontal circle, which of the following remains constant? A, velocity, B, acceleration, C, centripetal force, D, kinetic energy. Which remains constant?
Acceleration.
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 What about kinetic energy?
Kinetic energy means
All these are vectors, right? Velocity,
Sir,
acceleration,
velocity will not
centripetal
remain
force,
constant. Kinetic
all
energy
are
will not.
all are all are vectors, right?
Yes, sir.
So their direction, magnitude will be same, but direction keep changing, right?
Yes, sir.
So kinetic energy will not change because velocity, speed always remains constant. And it is a scalar. Direction is immaterial. So your answer is kinetic energy. Isn't it?
Yes, sir.
Yes, sir.
Tell me. Any doubt?
No, sir.
No.
I'll have little water and cup.
Kinetic energy.
Okay, so kinetic energy is the answer. All others are velocity. So your direction of velocity changing, acceleration changing. But kinetic energy means it's scalar, half mv squared. V is a speed, not velocity. Next, a particle of mass 10 kilogram is moving in a straight line. If its displacement is x with the time, is given by
Sir, can you please repeat?
Sir, please can you
a
repeat?
particle of mass 10 kilogram is moving in a straight line. If the displacement x with the time t is given by x is equal to t cubed minus 2t minus 10 meter. Then force acting onto it at the end of 4 seconds. Force acting onto it at the end of 4 seconds. How will you calculate?
So differentiation.
Yes, sir.
Yes, F is equal to ma, isn't it?
Yes.
Mass already we know, but A is not given. So you
Differentiate
want to
x
go
to
for
a.
second order differentiation. Velocity is equal to d by dt of x. That means 3t squared minus 2, isn't it?
Yes, sir.
Now this again we have to differentiate.
Sir, we can directly go for like d square by dt that way.
dv by dt. So how much will come? 60, right?
Yes.
Yes, sir.
So this is acceleration. Here we need in 2 seconds of time, right? 4 seconds,
So
right?
4. Yes, sir. 4 seconds.
So when time is equal to 4 seconds, acceleration is 6 into 4, 24 meter per second squared. Then F is equal to ma. M is equal to 10 and acceleration is 24. So answer is 240 Newton. B.
Yes, sir.
There are problems of pulley that you don't have, okay? Pulleys, based on pulleys you don't have. So that problems again.
Sir, based on integration is also not there, right?
Based on pulley.
Sir, the integration part only for derivation,
one?
right? Integration part.
This differentiation.
Not differentiation, sir. Integration.
What do you want with integration?
No, will it have numericals from that?
We'll see. Numericals means like this only numericals will come.
No, from
integrated
integration.
equations, it will be there.
From integration directly they won't show, like this kind of small problems will come.
Okay, sir.
Next one. Wait. A body of mass m, collides, a body of mass m collides against a wall with the velocity v, and bounds with the same speed, its change in momentum is, what? Final momentum minus initial momentum. Okay, so mv minus of mv minus mv minus 2mv, right?
Yes, sir.
Yes, sir.
Because while the ball is moving this side, it is mv. While coming back, it is minus mv. So final momentum minus mv, initial momentum minus of mv. So minus 2mv.
Sir, why, sir, it is why it is minus mv minus mv?
Minus?
Why the mv is having minus sign, sir? Because initial mv